Okay, hello everyone. Before starting today's session, let's talk about project deliveries. So as you see, there is 3 sections. Uh, last month you had the first one, which is the proposal, problem statement, data source description, and so on and so forth. You have almost 4 or 5 days to do the second delivery, which is you should do literature review, identify gap in the literature, research questions, significant study, and descriptive statistics, and visualizations. So visualizations mostly you can do it in Tableau, or similar. Also, descriptive statistics you can either do in Tableau, Excel, or even NIME helps you to do that. So regarding literature review, you should search for the recent paper related to your topic. In previous case, I had the exact same problem. Let's say you want to predict survival chance of maybe kidney transplant. So what you do, you go to Google Scholar, search for kidney transplant survival prediction. I clicked on the last one since 2020, and at least do 5 papers. You can do more than 5. Just click on them. When you click on each link, most likely if you are inside university, you can have a free access, and you can download it. So either in PDF, it will just, okay. What you do for literature review, for understanding what other people did and finding the gap, you can, if you don't understand the methodology part or mathematical part, that's totally fine. You just read the abstract and the last part, conclusion or result part, here is a little different. So statistical analysis. So you can understand what they did by reading the abstract and conclusion. Also, for finding the gap or what they address in the paper, you can read the introduction too. So usually in introduction, they introduce the problem, what they covered, and they contribute also some part of their contributions. If you know whole of the paper, it's easy for you to read, and you have time, you can read whole of the paper. But otherwise, abstract, conclusion, introduction helps you to do literature review. So right now I'm on campus. Most of our university subscribe to many data sources or databases of journals. But if you want to access from home or even sometimes from university, you don't have access to some certain papers, like one of my papers. Let me show you. Let me just put my name. Okay, this paper. As you see, there is no download option. When I click on get access, it just it doesn't mean inside the university you see something like link. Oh, it's very slow. There is an issue. Usually through the link you can order it, or also, let's say you want to access from home, or you're asynchronous or synchronous students out of United States. For you guys, you can contact the university, use the Clark VPN, and also contact university to get those papers. One of the things that university helps you is Iliad system, which is Intel Loan Library System. Iliad Intel Library Clark University. So you can place a request through this link and ask from university to search for the paper. They search for the paper and email the link to you so you can download. Any questions? So if there's no questions, let me start today's lecture. By the way, second delivery is October 23rd, and also the last one, almost the last class of next semester. You can do presentation either in the class or through the Zoom. I also recommend to do either of them. Otherwise, if you cannot present or have some issues, you can email me a YouTube video link so I can later read the video, see the video, and read your report. If you present in the class, either through Zoom or through your presentation, if I have any question, confusion, I can easily ask from you. Otherwise, it's much harder for me to understand what you did. So it's what I recommend is presenting the class. So hopefully I can understand the depth of your work. Okay, last week we understood formulation for the linear programming. So we don't, in this course, your main goal is understand how to formalize actual problems through the mathematical language, which is linear algebra, and let the computer to solve it for us. We also solve it manually through visualizations. As you've seen, for the human eyes, up to 2 or at most 3 dimensions is feasible, but more than that is really hard to visualize it. So for those reasons, we let computer solve it for us. The way that usually computers solve it, it's find all of the points in the feasible region and just check one by one which one maximizes or minimizes your goal. Any question about the previous session? So in next few weeks, we try some certain types of linear programming. So by exposing yourself how to write your problem from English to the mathematical format, you can let the computer to solve it. So for example, we try simple experiment, sensitivity analysis, integer programming, network modeling, goal programming, multi-objective optimization. So these are some major prescriptive analytics, or more specifically linear programming problems that you need to expose yourself, learn how to formalize it. So hopefully next time you can easily formalize a linear programming problem. So today we solve some linear program problems through using Excel spreadsheet. We learn about binding constraints, slack, surplus, shadow prices, and we look at 2 applications, make versus buy, and also a transportation problem. So before doing that, first of all, download the sample problem and solutions that I posted over Moodle. So, and also open an Excel file. I give you a couple of minutes to do that. Also, I posted a Word document about a reading. Please download that Word document too. So you should see 2 Word documents in your model. One of them is in-class problem, and the one more concepts. Okay, so we need to activate add-ins in the Excel to let us to solve linear programming problems through Excel. I put the steps here. We go options in here in the file section. So go to file, then options, then go to add-ins. Then here, go to select Excel add-ins and click on go. And here, select solver add-ins. Click OK. Now, if you go to data, you see you have a solver section. So go to the data tab and see this section. So basically, solver is the Excel add-ins that helps us to solve linear programming problems through Excel. I put the steps in your slide, so we can just. Okay, as a sample problem, let's look at the previous problem that we solved in the previous class, the meal plan. So we know the cost of each food. Sandwich costs us $5, hash brown $1, and we had 5 constraints. 4 of them about the specification of the food that needs to be delivered. Also, we have non-negative constraint. That doesn't make, say, -3 hash brown or -2 sandwiches. Okay, so just open your Excel file. What problem is that? Problem. Go to the first sheet, problem 1. Okay. We should find the amount of our decision variables, because by number of sandwiches and hash browns that you want to include, you can find the cost. Also, you can find if you follow the constraints or not. So these yellows here are my decision variables. I'm not sure what I read, but I have the coefficient. I know each sandwiches cost $5 and each hash brown costs $1. So what would be my total cost? Number of decision variables, sandwich or hash browns times their cost, right? whatever I put in the yellow cells would be multiplied to the coefficient, which gives me the total cost. So what can we do? We can find we can put the formula for finding the total cost. Look at the under total cell. I said total cost is this cell, C5 times C4 plus D5 times D4, and sum them up. Right now is empty or zero because there is nothing in my decision variables. I'm not sure what is my decision variables. So let's just put it. So now I have 4 constraints. Whatever, let's say I sell 2 sandwiches here and 2 hash brown. How many calories it would make? Can you give me an answer? So let's say my decision variables, which is the number of hash brown and sandwiches, both of them are 2. How many calories it would take? $1,217. Why? So each sandwich had 300 calories. So how many calories has 2 sandwiches? So each hash brown has 200 calories. How many calories is 2 hash browns? 400. So 400 plus 600? 1,000. So no. So whatever you decide for decision variable would tell you how many calories it take, how many proteins it take, how many fat it makes, and how many carbs it makes. Yes, very. So as you see, your decision variables are affecting 2 things. First, your objective function, right? Because we have the cost coefficient. We know one of them costs $5, another one $1. So what would be my objective function if I sell 2 hash brown and 2 sandwiches? Oh, sorry. If my meal plan has 2 sandwiches and 2 hash browns, how much does it cost? Yes, 2 times 5 plus 2 times 1, 12. So if both of my decision variables are 2, my total cost would be 12. And you can now, okay, one more. If I sell 3 sandwiches, 1 hash brown, how many carbs it makes? 180. Yes. Any questions? If it doesn't make sense, the calculations that I'm making now? Or even people over Zoom, do you guys, if you have any questions about the sample decision variables that we found and makes, I calculated how much of constraint and how much of objective function it makes? Okay, one question. Oh, no question. Okay, good. So anyway, I know my calories, if you look at the problem, should be more than 1,000, protein more than 60, fat less than 80, and carbs, I think, is more than 100, yes. So whatever I decide for my decision variables, tell me if I'm passing my constraints or not. If I sell 4 sandwich and 1 hash brown, how many calories it makes? 4 sandwiches, 1 hash brown. Yes. And 1400 calories is more than 1000, the capacity. So it's good, right? Because we seek, due to the problem, we seek anything more than 1000. What about fat? If I consider 4 sandwiches and 1 hash brown. So how much fat it makes? 90. So 90 is more than 80. So it's not good. Anyway, for letting solver to find it and check the constraints for us, similar to my objective function in the red cell here, I make constraints cell in these blues. So, for example, first one is the decision value, the value of decision variable times the calories coefficient. So, how much calories each one of them makes. Since my decision variables are empty or 0, the multiplication is 0. If they were 2, it was different. Similar for protein times decision variables, and everything up to the carbs. So whatever, let's say if I make a meal with 2 of them, 2 times 50 plus 2 times 30 would be 160, more than 100. So it's good. So basically, the red cell is our objective function formula, and the blue cells has my constraints formula. Let's say I make 10 and 2. So the cost would be 52, because 10 times 5, 1, 50, 2 1 times 1, 2. Objective function is 52. And you see how it affects my constraints, because I have formula constant. I know if I use 10 sandwich and 1 hash brown, how many calories, protein, fat, and carbs it makes. So, but I'm not sure if 10 and 2 is good. First of all, maybe it doesn't follow any constraint, and also it's not minimized. I'm going to minimize it. So you don't have to check one by one up until you find the best solution. You just let Excel does it for you. Okay, before getting to the solver add-ins, any questions so far? No? Okay. So go to Data tab, then click Solver. It's really easy. You need to define 3 things. First, you should say actually 4 things or 5. Let's just do one by one. So you can say my objective function cell. Look at here, E5, which is here, the red cell. Decision variables, the yellow ones. So here, I'm just saying my decision variable is everything between C4 up to D4. Also, you define your constraints. So let me just delete this one. I'm deleting one of them to show it to you. So let's look at the problem. The carbs that I make from my meal should be more than 100. The carbs that I make are in this blue cell. Oops. Just do it again, solver. Okay, here. I'm just saying blue has the formula for making carbs based on my decision variable, this blue, E10. I'm just saying that the carbs that I make should be greater than equal 100 that comes from F10. You see E10 greater than or equal F10. And you make other constraints one by one. For example, protein should be E7 should be calories should be more than 1000. Protein E8 should be greater than F8, and E9, which is fat in the blue cell, less than F9. For this option, first I'll say the unconstrained variables are non-negative. Basically, these are the variables that you have in the model, and there is no constraint for them. We just want them to be non-negative. Also, we ask simplest LP. This is the algorithm that we want to choose. For all of your problems, please choose simplex LP. And what was more? Let's see this. I think for the rest you can use as default. So for, again, you select your cell related to your objective function. This problem is minimization. We want to minimize the cost. You specify the range of decision variables here, C4 and D4. Also, you put the constant, make it non-negative and simplex function. Then we select solve. Okay, so look at the reports. We have answer, sensitivity, and limits. Let's just select all of them. Just press Control and click one by one. And press OK. As you see, now I have sensitivity report, limits report, and also answer report. So next time we talk about integer programming, but right now it's at 2.8 sandwich and 0.8 hash browns. That's okay. We would have a discussion about how to make decision integer programming. Here you see some parameters like slack, or here allowable decrease, increase. RH stands for right hand side, shadow price, reduce cost. I think this limit report is fine. You don't have to do that. Okay, please. Okay, I give you like a couple of minutes to play with the Excel file. You can just change, play, and see what are the results. Then I go to the next section. You just have a couple of minutes to work with that Excel file. Yes. Hmm. Okay, let me just count for you guys. I should check the video again. I'm not sure what I did previous time, but let's see. Maybe I made a mistake. Maybe I didn't click on the right cell for objective function, because now I checked that I got exactly the same result. When I checked that, actually, I just said I clicked E10, not E5. When I saw mine here was E10, then I changed it to E5. Then exactly same result. I guess I had it like I clicked in the wrong place. Okay, so, but that's a good catch. Thank you. Okay, let's talk about some concepts that you can see in the reports. The first one is binding constraint. The constraint that participate in the final solution. What does it mean? Assuming that in the two-dimensional problem, intersection of two constraints is a point, and that point is your optimal solution. So we call it binding constraint. Super, or basically, more interestingly, but it could be out of content for this class, but for binding constraint, left-hand side and right-hand side are equal. There's a mathematical reason for that. So left-hand side is multiplication of your, let's say for calorie times to your decision variable. So for so here, let me just show it here. Okay, let me solve it again. Okay, this one E5, everything's fine. Let me select. So we have carbs, calories, protein, and fat constraints. These are the values. So total, if you use 4 sandwich and, sorry, 4 hash brown and 2 sandwiches, look at the constraint here. 2 times, sorry, how much was that? 2 and 4, okay, 2 and 4. 2 times 300, 600. 4 times 200, 800. 800, 600, 1400. So 1400 is my left hand. The right hand is my constant, which is 1000. So left hand side, which is the blue cells, are not equal with the right hand side. So my calorie constraint is not binding, because based on my decision variables, multiplication of the coefficient to the decision variables is not equal to the right hand side. Let's check protein and fat. So for protein, 2 times 20. So anyone can tell me the protein constant is a binding or it's not binding? Is a binding constant or unbinding constant? The right hand side is 60. Is a binding constant. So is, what about calories? Is it binding or it's not binding constant? It's not binding because left and right side are not equal. So as you see, you could be either more than your constraint or less than your constraint. Usually they define as surplus and slack, but in some softwares, they use one term for both of them. You can see instead of defining surplus as amount by which left-hand side of the greater than equal constraint exceed the right-hand side. Slack, the amount by which left-hand side of less or equal to constraint lags the right-hand side. Look at here. Which one was greater, protein and carbs? So protein is not a binding, carb is not binding. This is a slack or surplus. So first of all, the constant is greater, right? Greater than equal, surplus. For a slack, the amount by which left-hand side of less than equal to constraint lags its right-hand side. So here we have one less or equal, which is for fat. Let's check fat. So first of all, is it binding or non-binding? Binding. And what is my, here I have a slack or surplus. It's 0, basically the difference is 0, but says less or equal, slack. So this is a more technical definition. So for greater or equal, we call it surplus, for less or equal, we call it slack. But in some softwares, they define both of them in the same way. They call both of them slack. Let's look at Excel. So as you see, we don't have any column for the slack or surplus. Both of them are called the slack. So it's the way that Excel works. But some softwares, they differentiate between Excel and, sorry. Oh, excuse me. So in some softwares, slack and surplus are different. In Excel, both of them either is less or equal or greater than or equal. Both of them are named as slack. So if you just use the slack, you don't have memorized both of them. If your left answer and right answer are not equal, you have a slack, and that's it. Shadow. Yes.
What important that we define a binding constraint or non-binding? What important?
So actually, you want to learn the language of the linear programming, how to communicate with other people. Basically, if the constant is binding, it just means that's those constraints make your optimal solution. So for example, in the two-dimensional space, intersection of two binding constraints is a point that is your optimal solution. I know we don't go to the reason for that. There's a mathematical reason for that. But you can assume that binding constraints are participating in your optimal solution.
Okay.
Shadow price, the change in the objective value when a resource, either a constraint or is relaxed or increased by 1 unit. Keep everything else constant. So what happens if you relax your constraint by 1 unit? What happens to your objective function? Where is that? Shadow price. So look at here, carbs and calories, they have 0 shadow price. Also, they are not binding. It's a little out of context for this class. I just want to, this is what, the thing that I'm explaining now is a little extra. So no worries, it's not needed for your work. But I'm just teaching you to be able to communicate with other people. So I told you that binding constraints are participating in the optimal point. What does it mean? The optimal point is the constraint of 2 or 3 binding constraints. So let me use my board.
Oh, Hamid, sorry, I cannot hear you.
Can you hear me?
Yes, thank you.
I'm sorry. So I just said this is my feasible region out of 4 constraints, 1, 2, 3, 4. The blue in the middle is my feasible region. And this one is my optimal solution, this point intersection of constraint 3 and 4. So what happens if I change my constraint 1 and 2? If I change 1 and 2, it doesn't have any effect on this optimal solution. So I say the shadow price of constraint 1 and 2 are 0. And also, they are not binding constraints. So basically, shadow price of 0 and on non-binding constraint just means they are not participating in the optimal solution. When your slack is 0 or your constraints are binding, it just means something like, let's say, call it the star point. It means you have something like star points. Any constraint, if you change those constraints left and right, your optimal solution would be changed a little bit. So, and the change in the value of the optimal solution would be called shadow price. It might make it better or worse. The software would tell us. Also, constraint 3 and 4 has slack of 0. Basically, slack of 0 means binding constraint. Also, shadow price means what happens if you change the constraint by 1 unit. What change it causes in the shadow in the optimal solution? If the constraints are binding, it probably change. We should see that. If my constraints are not binding, like 1 and 2, it doesn't have any effect, and the shadow price is 0. So shadow price of non-binding constraints is 0. As you see, they don't have any effect on binding in the optimal solution. Any questions so far? No? Hopefully it makes sense.
So just one thing.
Sure.
In surplus and slack, in both of these places we are talking like if the left hand side equals to the right hand side.
Mm-hmm.
So if it equals, we'll be calling in both cases slack.
Yes, in the Excel we call it slack. But I said in most of softwares, when the sign of inequality is greater, we call it surplus. When the sign is less, we call it slack. But in Excel, both of them are called slack. Okay, so let me just go one more thing. Okay, let's talk about allowable increase or decrease. Maximum change from the current coefficient that keep the optimal solution. So look at here. This is about my constraint. It's just saying how much I can change my constraints, either increase or decreasing, without changing my optimal solution. When it's more than 2 dimensions, it's a little difficult, but as you see, for carbs and calories, you can increase them. Sorry, you can decrease them to 0. Is unlimited. But we have a binding, they're non-negative. You cannot make them negative actually. And you can increase 120 or 400. It doesn't change my optimal solution. Also, you can change. You can increase protein and fat by 20 or 40, or decrease them by 20 or 60, and it doesn't change your optimal solution. It just say how much flexibility you have on the constraint. Basically, this thing that I'm talking about is generally they call it sensitivity analysis. So we can talk about binding constraint, surplus, slack, shadow price, allowable increase or decrease. Just see how sensitive is our optimal solution. And the last one, reduce cost. The amount by which an objective function coefficient would have to improve to be included in the solution. So let's say you have here, actually, we don't have any reduced cost. Let me just, both of them are 0 because both of them are included. You don't need to improve the cost of hash brown or sandwiches. But let's say you are doing a marketing and you can see if people make a very wise decision based on the cost. For example, nobody buys a veggie hot dog. Maybe you can play with the cost of veggie hot dog to be included to your optimal solution. I know there is some paste and other factors are included. I'll just say you assume that if let me just makes one of my coefficients very expensive here. Let's say instead of 5, I make it 500 or 500. Let's see what happens. So I go to solver. Let me this time I select correctly, hopefully. I don't want to make any. Still they are included. So I think it's because of just playing hard to exclude it from the solution. Hopefully it happens. So this time. Okay. So okay, let me change this one. Make it $2. This one 500. If it doesn't help, next time I bring a problem that. No. Okay. Okay, this problem for some reason doesn't make any. So, but anyway, since we have both of the variables in the problem, there is no reduced cost. But next class, I provide another example. When you change the, some of your values won't be included. So you can see how much you can improve your option, the coefficient of the decision variable, for example, here cost. So your variable would be included. So again, here, 0 cost. Let's see, what was the issue? So 300, 250. Anyway, oh, I have, no, not the issue. Okay, anyway, that's for today. I think I taught too much, and it's first time you exposed to so many new things for today. You have seen that you can use software for solving the problems. Also, we reviewed some concept here like binding constant, surplus, slack, shadow price, allowable increase, decrease, and reduce cost. Today we didn't have any example for reduce cost. It's 0 because both of the hash brown decision value and sandwiches are in the model. So next time we have another example that we have reduced cost for some variables. So you can put them in the model. So up to the next class, you have. I also put some other problems that I review next class, like transportation plan, how to distribute your goods, and also sell or buy problem. You can do some study in advance, but next class, no worries. I solved these 2 problems, and you exposed to the Slack, and also we talked further about sensitivity report. Any questions? That's it. Again,
Yes.
Okay,
Professor, I have a question about the presentation. Do we need to do the introduction presentation next class?
No, you don't have to. There is no presentation. The only presentation that you have is for final submission.
Okay. Thank you.
Thank you. Any other questions?
I think we made one video presentation.
You made?
I think we made and we submitted to you all, I guess. We had one due, and then we said us to submit, record and submit it.
But there is no submission for the second. Yeah.
I think we had one.
Okay, cool.
Probably for the Titanic, yeah.
Mm-hmm.
Titanic data set.
Yeah.
And Professor, can I use Excel or SPSS for the statistics part in the project deliverable tool?
Visualization should be in Tableau.
Is it
Yeah.
the statistics part, because this is the time series data, so I have to check the just
Okay, you can.
and the rest of the data.
Mm-hmm.
And this I can do in SPSS. So
Go.
okay, I can use the SPSS and paste the output in the
Sure.
report.
Okay, so if there is no other question, that's for today, and have a good rest of the day.